basic math skills self-test number 4 is very similar to 1 through 3. However, I've changed a few things, added a few things, made it a bit more challenging. So if you see something that you just can't figure out, give it a try and then see how it's done. This self-test has 20 different problems for you to try. When you see a new problem, click on the stop sign. That'll pause the video if you're watching it on YouTube. Then try to work the problem on a piece of scratch paper. Then click on the go sign to start the video, and you'll see the problem worked out. Number 1, turn 1.375 into a fraction, then simplify your answer. Click on the stop sign. Alright, let's see how you did. Well, we know that we don't have to pay any regard to the decimal when we're taking a look at what our numerator will be. Our numerator in this case will be 1.375. And our denominator will have 1, 2, 3 zeros in it because there are 3 places to the right of the decimal, and all of that will come after a 1. So we have 1,375 over 1,000. Now we want to simplify that. So it turns out that 125 times 11 is equal to 1,375. And it turns out that 125 times 8 is equal to 1,000. Now we have a 125 in the numerator and we have a 125 in the denominator, so they cancel each other. They just become the number 1. And so 1 times 11 is 11, and 1 times 8 is 8. And so we have now simplified this to 11/8. Now we have an improper fraction. 8 will go into 11 one time, and that will leave us with 3 left over, and we're dealing in eighths. So the answer is 1 3/8, and if we wanted to check to see if we were right on that, we would say 8 times 1 is 8, plus 3 is 11, and 11/8 does equal 11/8. Number 2, turn the fraction 4/15 into a decimal. Click on the stop sign. Okay, let's see how you did. It's just a long division problem, so we'll put the 4 on the inside and the 15 on the outside, and we know that 15 will not go into 4. This is smaller than 1, so we're going to have a 0, and then we'll add a decimal. Then that means we can add a 0 down here, and 15 will go into 40 exactly 2 times, and that's 30. And we do the subtraction, and that leaves us with 10 left over. 15 will not go into 10, but it will go into 100 exactly 6 times. Not exactly 6 times, but 6 times. 6 times 15 is 90, and that leaves us with 10 left over, and 15 will not go into 10, but it will go into 100, and it will go 6 times. So we're in sort of a little loop here, and so we have 90, and we do the subtraction, and that leaves us with 10, and so we would have 0.2666666 forever and ever. So we'll put a line over this. So our answer is going to be 0.266, correct to 3 decimal places. We could make it correct to 4 decimal places by adding another 6, or we could just say it's 0.2 correct to 1 decimal place, or 0.26 correct to 2 decimal places. So it just depends on the level of correctness that you want when you're dealing with a repeating decimal. Number 3, turn the decimal answer that you got for the number 2 into a percentage, and so you need to click on the stop sign. Alright, let's see how you did. Well, it was 0.266 correct to 3 decimal places. We just shift the decimal 2 places to turn it into a percentage, because percentage just means per 100. So it's some number over 100. So if we add 26.6 over 100, that is 26.6%. Number 4. All units are in feet. The rectangles are proportional. What is the length of the x's if the larger rectangle has been dilated by a scale factor of 2? Click on the stop sign. Alright, let's see how you did. Okay, what does this mean? Well, first of all, we look down here and it says not to scale. What that means is this is a drawing. It's like a sketch, and it's not to scale. We couldn't take a ruler and measure this and try to come up with some answers. The numbers are correct, but that's what it means when it says not to scale. Okay, this larger rectangle has been dilated, or is a dilated version of the smaller rectangle by a scale factor of 2. That just means whatever this length is, we multiply it times 2, and we get this answer down here. And whatever this length is, we multiply it times 2, and we get this answer over here. So 2 times 4 is 8. So this length is going to be 8. And let's see, some number times 2 gives us 11. So if we take 11 and divide it by 2, that gives us 5.5. So we're dealing with 5.5. Now, what's the length of the x's if the larger rectangle has been dilated by a scale factor of 2? Well, this one is 8 feet, and this one's 5.5 feet. Alright, number 5. It's the same drawing. It's exactly the same drawing. All units are in feet. What is the area of the smaller proportional rectangle? We don't know this information, but we do know that this line is twice as long, it's been dilated by a factor of 2, is twice as long as this. So half of 11 is 5.5 feet, and this is feet over here. And the question, and it's a good idea to always go back and reread the question and say, okay, am I really answering what they're asking me? And it says, what is the area of the smaller proportional rectangle? Well, how much area is here? Well, we know that our answer is going to be in square feet. So we'll just square feet. That's going to be our answer. That's going to be the units connected to our answer. And to find the area, it's just length times width. That's to find the area of a rectangle. So we take a look at this and we say 4 times 5.5. So I do the multiplication here. This is multiplication. So 4 times 5 is 20. That's a 0. I carry my 2. 4 times 5 is 20. That's 22. 22. And I look up here and I have 1 decimal place. So I add my decimal in, and I'm at 22 feet squared. And that's the correct answer. Number 5. The square root of 9.4 is between what two consecutive whole numbers? Click on the stop sign. Okay, let's see how you did. Well, let's take a look. The square root of 9.4. Okay, we have 9.4. I want to know what the square root of that is. I'll just make a number line down here. You can maybe visualize that. And it's between what two consecutive whole numbers? Well, consecutive whole numbers, what are those? Those are just things like 6 and 7 or 11 and 12. It's two numbers that come next to each other on the number line, two whole numbers. So we take a look at this and we say the square root of 9 and the square root of 16. I would hope that it's obvious to you that the square root of 9.4 is between the square root of 9 and the square root of 16. However, I chose the square root of 9 and the square root of 16 because they work out evenly to consecutive whole numbers. And so the square root of 9 is just 3, and the square root of 16 is just 4. So that means that the square root of 9.4 is on the number line somewhere over here. Exactly what that is beyond the scope of what we're trying to cover here. Number 7. The triangles are proportional. What is the angle measure of the unknown acute angle? Click on the stop sign. Alright, let's see how you did. Well, you should know that all the internal angles, this angle plus this angle plus that angle, equals 180 degrees for all known triangles in the universe and beyond. So, if we just total those up, well, this means that this is 90 degrees. That's what that little thing means here. So we have 90 plus 37 plus x equals 180. And we're all talking about degrees here. And what it's asking us is, what's this angle measurement right here? Well, if they're proportional triangles, then we know that this is 37 degrees. And so we know that 90 plus 37 plus x over here is going to equal 180. So we just set it up in a mathematical way and then solve for x. So we have 90. I'm going to leave off the degree marks because we know we're dealing in degrees. That's a little sloppy, but I'm going to do it this time. 90 plus 37 plus x equals 180. Now, if I subtract 90 from each side, this 90 just goes away, and this 180 becomes 90. So now I have 90 equals 37 plus x. So now if I subtract 37 from each side, I'll find out how much x is. And so x equals 53. And I can plug that number back in just to check. It's always a good idea to kind of go back and check to make sure you did everything okay. So now I have 90 plus 37 plus 53 equals 180. And I can check that. And it turns out that 90 plus 37 plus 53 does equal 180. So the question was, what's this angle right here? It's 53 degrees. Number 8. Make a sketch of the coordinate plane, then sketch a circle that has a radius of 1.5 and is centered at the ordered pair 0, 2. Click on the stop sign. Okay, let's see. We're going to make a sketch. Looks to me like this is going to be in the first and second quadrants. So I'm not really needing to do a whole lot here. I didn't spend a whole lot of effort drawing anything of the third and fourth quadrants, which are these two down here. So now it says I've got to locate the center. My center is x is 0, so here's where x is 0. And we'll just say 1, 2. That's 2 up. And just to keep things straight, I'm just going to add x is 1 and x is 2 and x is -1 and -2. And so now it says locate the center. Well, my center is going to be right here. And it says the radius is 1.5. So this dot right here will fall on the edge of the circle, the circumference of the circle, and this dot right here will fall on the circumference of the circle. It's not perfect because I'm just making a sketch. And so 1.5 here, that would fall on the edge of the circle, and somewhere up in here would fall on the edge of the circle. And so now what happens is I've given myself a target, something to kind of hit so that I can freehand sketch in my circle. So if you drew something that looks about like this, you're doing it right. Congratulations. Number 9. Just multiplying some fractions and a decimal. Ooh, you got to do a little decision making here. Click on the stop sign. Okay, let's see how you did. Well, multiplying fractions is the easiest thing to do with fractions because you just multiply the numerators and you multiply the denominators and simplify as necessary. But now we have a decimal thrown in here and we've got to multiply that. So you have to make some decisions. So what I'm going to do is I'm going to turn 2.2 into a fraction. And that's just 22 over 10. And it's over 10 because I only have one decimal place to the right, or one number to the right of the decimal. And so that means I have 1 0 here. So we're dealing, this is 2 2/10 is what that is. And so I have 22 as my numerator and 10 as my denominator. Now I can just multiply pretty straightforward through. So I have 9 times 1 is 9. Times 22 is going to be 198. So my numerator is going to be 198. And now I can come along and say 15 times 2, that's 30, times 10 is 300. So I'm 300. That's the fraction, but now I need to simplify it. First thing I would do, looking at something like this, is say, well, they're both even numbers, so it's easy for me to cut them in half. So this is 150, and this will give me an equivalent fraction, and half of 198 is going to be 99. The next thing I would do with this is I would look at it and say, this is divisible by 3, and this is divisible by 3. So 3 times 33 is 99, and 3 times 50 is 150. I have a 3 in the numerator, and I have a 3 in the denominator. They cancel each other out. They just become 1. And so now I have 33 over 50. And I look for common multiples in 33 over 50. I know that 3 will go into 33, but 3 won't go into 50 so well. I know that 5 will go into 50, and so will 10. But I don't see that a 5 will fit in 33, and I don't see that a 50 will fit in 33. And I can divide this one in half, but I can't divide this in half and get whole numbers. Oh, I think I'm finished. So, the answer that I get is 33 over 50. Number 10. You're dividing 9.2 by 1/2. Click on the stop sign. Okay, well, we have some number, and we're dividing it by 1/2, and we know that when we're dividing a number by 1/2, we just flip over the dividing fraction, and the numerator becomes the denominator becomes the numerator, and then we just multiply. So now I have 9.2 times 2 over 1, and 2 times 9 is 18, 2 times 2 is 4, so I had 18.4. 18.4 over 1, and that's just 18.4. And that's the correct answer. Okay, what's the area of the hexagon? All units are in meters. Now don't be intimidated by this. You know enough math by now to figure out what this is. So really think about this, try, then come back and see how you did. Click on the stop sign. Okay, I would look at something like this and think, all right, boy, it doesn't seem real obvious, but you know, if I can cut this up into pieces that I can understand, then I can calculate the area. So if I just were to draw a line right here, I now have a trapezoid, and I have a trapezoid, and I know how to find the area of a trapezoid. And so I have base 1 here and base 2, that's 7 meters, and the height is 5 meters. So refreshing your memory, the area of a trapezoid is equal to base 1 plus base 2 times the height, all divided by 2. So, I can take a look at this and say base 1. Now, bases, those are just the parallel lines, and it doesn't matter which one you call base 1 or base 2. I simply have here 4 plus 7, and I get the same answer if I add 7 plus 4. And so 4 plus 7, that's just 11. And I'm going to multiply that times the height, and that's 5, and we're dealing in meters. And I'm going to divide that by 2. 11 times 5, that's 55. Divided by 2. And by the way, this times this is going to give me 55 meters squared. And because this is meters in one direction and this is meters in another direction, and it's an area thing that we're seeking. Okay, now 55 divided by 2 is 27.5. Okay, so I have 27.5 meters squared. But 27.5 meters squared is just the area of this side, and I need to know the area of this side too, so it's just doubling that. So if I double 27.5, I come up with 55 meters squared for the total area of this hexagon. So I know it was a little challenging, but don't give up. Keep hammering away at something. Cut it up into little pieces. Try to figure out how to actually solve the problem. We need people who can solve problems, and that's you. All right, number 12. Make a sketch of the depiction below, and then rotate the figure 90 degrees around the origin. Click on the stop sign. Okay, what does this mean? Well, the origin, that's just where x and y are 0, and x, y, and z are 0. So this is the origin, and a 90-degree rotation. Now this is the positive direction that we have for rotating something. So rotating it 90 degrees would rotate it in this direction here, around the origin, and so we would wind up with something that looks about like this. And rotated, so if we rotated this around this way, we would wind up with something that looks like that. Number 13, dilate the red box by a scale factor of 2. Click on the stop sign. Okay, what does that mean, dilate the red box by a scale factor of 2? Whatever this dimension is right here, we're just going to double it. So I'm just going to kind of guess, and then this dimension right here, I'm just going to double it. So I'm just going to guess a little bit, and then I'm going to kind of freehand in a box. And I wind up now with a larger box that's dilated by a factor of 2. Now since I dilated it in the x direction by a factor of 2, and since I dilated it by a factor of 2 in the y direction, I wind up with a drawing that's not twice the size of what I had, but 4 times the size. So if I'd done this exactly correct, this larger rectangle would be 4 times larger. But I only multiplied it by a scale factor of 2. 2 in the x, 2 in the y. Number 14. What is the area and perimeter of a right triangle that has 2 legs that are 8 feet and 10 feet and a hypotenuse that is 12.8 feet? Click on the stop sign. Okay, it's my strong recommendation that you make a sketch of what you're doing here. So you look at this and you say, all right, one of the legs is 8 feet and one is 10, and the hypotenuse is 12.8. And all these are in feet. So the perimeter, well, that's the easier one to do. That's just perimeter. That's the total distance around. It's the edge all the way around. So we have 8 plus 12 is 20.8 plus 10 is 30.8. So our perimeter equals 30.8 feet. Now it says, what's the area? Well, the area, you have to know the formula. So the area is nothing more, the area of a triangle is nothing more than plugging in the right numbers in the right formula. And the right formula for the area of a triangle is the base times the height divided by 2. Or it could be the base times the height multiplied times 1/2, because multiplying times 1/2 and dividing by 2 are the same thing. Okay, our base is 10, and our height is 8. That's 80. 80 divided by 2 is 40. But 40 is not the correct answer, because that's just a number. I have to say what it means, so it's 40 feet squared, because we're looking for area. Number 15. Sketch a cube and name or label 3 main parts. Click on the stop sign. Okay, this is a little bit tricky because we only have 2 dimensions here, and we're trying to sketch something that looks like it has 3 dimensions. One of the ways that you can kind of sketch something that looks like it has 3 dimensions, but do it only in a 2-dimensional plane, is to do something about like what I just done here, and something like that, and like this, and then like that. It's not perfect, but there I've sketched a cube. And name the parts. Well, this would be a face, so we have a face here. It's called a cube. This is a vertex. It's where everything comes together. It's where these 3 lines come together. The inside of the cube is volume, so we now have some volume that we can deal with. This is the edge. This is the perimeter of one of the faces, so we have the perimeter that's there. So those are some of the main parts of a cube. Number 16, adding and subtracting negative and positive integers. Click on the stop sign. Okay, let's see how you did. Well, we have 11, so I'm just going to freehand draw in a number line here, and I'm starting at 11. So I have 11, and then I'm going to subtract a negative 10. Well, taking away a negative is always a positive, so that means I'm going to add 10, so that'll take me up to 21. So now I'm at 21, and so I'm here on the number line, and then I'm going to subtract, or I'm going to add a negative 32. So subtracting 32 from 21 takes me down to negative 11. So now I'm at negative 11 on my number line, and then I'm going to add negative 9. So I'm going to go in this direction 9 more units, and that takes me to negative 20. So my answer is negative 20. One of the ways that I remember that helps me, remember I have two ways that I can remember. How do I deal with subtracting a negative? Well, if I take this little line right here and use it to make this a positive, then that means it's no longer over here. And so now I have 11 plus 10. And 11 plus 10 was 21, and that's what we got. Another way that I can deal with that is if I remember that taking away a negative is a positive thing. It's that way in your life too. If you have a negative thing in your life and you take it away, well, that's a positive thing. Number 17, what are the measurements on the ruler below? Click on the stop sign. Okay, let's see how you did. A, well, let's see, the distance from here to there is 1 inch, and we look at it and we say, okay, well, this particular ruler is divided into 16ths because there are 16 little marks, 3, 4, 5, 6, 7, 8. There's 16 little marks between the 0 and the 1, and what's really good and interesting about this is that they're the same 16 little marks between 1 and 2, and they're the same 16 little marks between 99 and 100. So the reason we're taking a look at this end of the ruler here is that if you can know this measurement right here, or you can know this measurement right here, you can know any measurement on the ruler. You don't have to learn a whole bunch of them. You just learn those that come between the 0 and the 1. Sometimes you'll see that little marks here, there are only 8 between the 0 and 1, and then you're dealing in 8s. But in our case here, we're dealing with 16ths. So all right, we go 1/16, 2/16, 3/16, 4/16, 5/16, 6/16, 7/16, 8/16, 9/16. A is 9/16, and I can't simplify 9/16 any more than it already is. Now, I know that the distance here to 1, this is 16/16. So I'm at 17/16, 18/16, 19/16, 20/16, 21/16. So B is 21/16. But that's not the best way of saying it. If you said to somebody, I need you to cut me a little piece of wood there at 21/16, they'd think you were stupid. But what we have here is this is 16/16, so this is 1, and this is 1/16, 2/16, 3/16, 4/16, 5/16. So 21/16 is the same thing as 1 and 5/16. And we're dealing in inches, and the little marks we use, 2 little marks like that mean inches. Remember, 1 mark means foot. Okay, now, let's see. We want to know what C is. 1 inch, so there's 16/16. So that's 1, and this is 8/16 because it's halfway there. 9, 10, 11, 12, 13, 14. 1 and 14/16. 1 and 14/16. But we can simplify that a little bit, and that's the same thing as 1 and 7/8, and we're dealing in inches. All right, the last one, D. Well, we're at 32/16 here if we were to count them all, or we could just say this is 2 and some other amount. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We're at 2 and 12/16. But 2 and 12/16 can be simplified, and that is the same thing as 2 and 3/4. And we're dealing in inches. Number 18. How many hours are in 77/3 minutes? This is a strange one, but you can do it. Click on the stop sign. Okay, 77/3 minutes. Wow, how many minutes is that? Well, let's go ahead and turn that into just how many minutes that is. So this is just a top in, bottom out kind of thing, and that'll give us the minutes. So 77 goes the top in, and 3, so it goes 2 times, and that's 6, and that gives us 17. We did a little subtraction there. And 3 goes into 17 5 times, and that's 15. We do the subtraction, and that gives us 2. 3 will not go into 2. We'll add a decimal here because we're at the end, but it'll go into 20. 3 will go into 26 times, and that's 18. And that leaves us with 2. So we see that immediately that we're going to be in some little loop here. So it's 25.6666666. So that's 25.66 minutes. That's how many 77/3 minutes is. But the question is, how many hours is that? Well, this 25 minutes that's less than an hour, so we know that our answer is going to be 0 point something. So let's multiply 25.66. Let's multiply 25.66 minutes times 1, and that'll convert it to hours if we put minutes. So we know that 60 minutes is exactly 1 hour. And you see, 1 hour, 60 minutes, it's the same amount of stuff on the top and the bottom. And when you have the same amount of stuff in the numerator's position as the denominator's position, this is just 1. So we're multiplying 25.66 minutes times 1. And that'll give us the same answer. But since we have minutes in our numerator position over here, and I say numerators because we could just put 25.66 minutes over 1. That makes it a fraction. If we multiply 25.66 minutes times 1 hour over 60 minutes, minutes are in the numerator and they're in the denominator, so they cancel. And so now I have 25.66 times 1. So I have 25.66 hours over the pure number 60. And this just becomes then a fraction, 25.66 over 60 hours. And you know how to deal with this. It's just a top in, bottom out thing. We wind up with 0.4276, and the 6 is a repeater. So the question was, how many hours are in 77/3 minutes? Well, 0.4276 hours, or less than half an hour. Number 19. Nikka charges $10 per hour for her services. If she works 1 to 10 hours per day for 9 days, what is the range of her gross pay? click on the stop sign. Okay, let's see how you did. Well, let's see. She works 1 to 10 hours per day. So on day 1, she either works 1 hour or she works 10 hours. And she's going to work for a total of 9 days. So we can multiply both of these times 9, and we wind up with she either worked 9 hours or she worked 90 hours. So the range of the time that she worked was either 9 hours to 90 hours. But she makes $10 an hour for her services. So we'll multiply that times 10. That's bucks. And there we go. So 9 times 10 is 90. And 90 times 10 is just 900. So she made somewhere between 90 and 900, because range, remember, is what's the bottom number, what's the lowest number, and what's the highest number. So the range was 90 to 900. Gross pay, that just means the total amount. No deductions, no, if she had to buy some paint and she didn't charge for the paint, then that paint would come out of this. So the gross pay, how much money did the customer actually pay? Okay, number 20. Well, give it a whirl. Okay, well, we know that PEMDAS teaches us the order of operations, that the first thing you need to do is that which is in the parentheses. So we will just multiply 4 times 2, that's 8. And 9 times 7, that's 63. So this is just the fractional form, 8/63, and we're going to divide that by 1.07. Well, we know that when we're dividing by a fraction, you just flip it over and multiply. So what I would do is turn this into a fraction so that I'm just multiplying a fraction times a fraction. And so 1.07 in a fractional form is 107. That's my numerator. And my denominator is going to be 100, because I have 2 numbers to the right of the decimal here, and so now I just have 100. So that's the fraction, but now I'm going to flip it over. I'm going to multiply this times 100 over 107. Now it's just a straightforward multiplication problem. I have 800, that's my numerator, and my denominator is just 63 times 107. And that is 6,741. 6,741. Now, simplify this. Wow. Well, it doesn't look like I can cut it in half very easily, because this is a 1. So, or I could just do the top end, bottom out, and come up with a decimal answer. Depends on what you're being asked to do. And we look up here, we had fractions and we had decimals. The easiest thing to do in this case for me would be to do the long division and figure out what the answer is in a decimal. And the quick calculation on that comes up with it's 0.1186. And that's correct to 4 decimal places. So it goes on after that. So what's my answer? Well, if I needed my answer correct to 4 decimal places, there it is. However, I had this is a decimal up here to only 2 decimal places. So by tradition, you might say that the answer is 0.11. If you got this right, or you understand now what you needed to do differently, great. I am proud of you, because you are trying. And that's what we need, people who try, people who don't give up. This is the end. You're now ready to try another basic math self-test. You may contact me at alanmorris@yahoo.com.